Pro Tools Matrix II provides a comprehensive solution for working with immersive audio for Dolby Atmos, whether working with music or post-production, from routing to and from the Dolby renderer via Dante or Thunderbolt 3, to providing precision-calibrated monitoring with dedicated DSP for tuning and bass management. For this tutorial, we'll examine configuring the Dolby Atmos renderer, leveraging DADMAN for I/O routing and immersive monitoring, connecting Pro Tools Ultimate, plus additional software applications for metering and QC. We'll be configuring the Matrix II and pairing it with an HDX2 playback engine within Pro Tools. The Thunderbolt 3 option module has been installed, which we'll be using as the I/O format of choice to patch to and from the Dolby Atmos renderer. We've also added several expansion cards to the Matrix II chassis to provide analog inputs, analog outputs for connecting speakers, plus a DigiLink expansion card to augment the integrated DigiLink ports and provide 128 total channels of I/O for Pro Tools. Before we start configuring the Dolby Atmos renderer, let's first access the Audio MIDI Setup application found on the Mac under Applications, then Utilities. From here, we can access the driver configuration for the Thunderbolt 3 option installed in Matrix II. Simply click on Matrix II, listed under the audio devices, then right-click and choose Configure Device. Within the Thunderbolt driver panel, we'll set the channel count to maximum, 256 channels. Then set the sample rate to 48 kHz for this example. This will provide us with a large number of host channels to share between the Dolby renderer and additional audio applications on the workstation. Now let's open the Dolby Atmos renderer, where we can access the Preferences menu and configure the environment to take advantage of Matrix II. Since we're on a Mac OS-based system, we're using a core audio driver, and we can select Matrix II for both the audio input and the audio output device selection. We're connecting I/O from the renderer using the Thunderbolt 3 option, which we just configured within Audio MIDI Setup. For this example, we'll be using the Dolby LTC plugin to send positional timecode from Pro Tools into the Dolby renderer. So we'll select channel 128, the last available channel from our HDX2 system. Let's enable headphones and make sure they're set to binaural, which we'll send to our Dante-based headphone amp via the Matrix monitor profile. We'll also be taking advantage of re-renders for metering and confidence monitoring, so let's enable that option here as well. From the Setup menu, access the Room Setup, where we can tell the renderer how many loudspeakers we have within our Dolby Atmos monitoring environment. For this example, we're going to set up a 916 configuration. The renderer also provides the flexibility to create monitor layouts from 514, 712, 714, etc. We can even switch on the fly to see what our mix will sound like with different speaker setups. Since the renderer defaults to 714, we simply need to add the wide speakers, plus the top mid speakers to achieve 916. From the next tab, Routing, we need to correlate the loudspeakers with the channels each is using to output via Thunderbolt 3 and into the Matrix II. For our path order for channels 1 through 16, we'll be using 916 Dolby, which starts with a standard SMPTE order for the floor speakers, then adds in the wides, and finally the 6 elevation speakers. For our binaural headphone reference, we'll assign to the next available pair, channels 17 and 18. Lastly, any re-render sets that we configure will start at channel 19 and end at channel 82. As a backup, choose Setup, then Export Global Settings to save a configuration file containing all of your routing changes. Next, we'll dive into DADMAN, the dedicated networked software application for control and monitoring of Matrix family devices. Let's start by doing some simple labeling and configuration. In this Matrix II, we have a single 8-channel AD mic preamp card and 2 8-channel DA analog output cards, so we'll simply add numerical labels to the individual strips. As mentioned, we're monitoring in a 916 configuration, so we'll label the DA output channels accordingly, which feeds the output to our 16 loudspeakers. From the configuration section at the bottom of DADMAN, we can adjust the Adapt To parameter to ensure that if we change the sample rate within our Pro Tools session, Matrix II will look to the DigiLink port to match the detected rate. It's also a good idea to label any digital I/O added into the Matrix II frame, such as DigiLink. We'll add some simple channel range notes for each of the 4 32-channel DigiLink ports we've connected, including the 2 built into the chassis, and the last 2 which are on the DigiLink expansion card we installed. Now let's start to build up our primary monitoring setup by accessing the Settings menu, then Monitor Profile. Since we're starting from scratch, we need to first select our Matrix device, then tick Enable Monitor to begin. Right-click anywhere within the monitor window, then choose Add Monitor to create our primary monitor, which will be called Control Room. We'll change the monitor mode to Master so that we can audition other monitors contained within our profile, which are defined as cues, including submixes for talent and other source groups. Yukon will see this monitor as the main control room, so it will be prominently displayed and controlled from our S6 or U-Control-based devices. Let's tab over to Group Formats and create a template for any 916 paths that we use as either sources or outputs. We'll create a new group under Custom Formats, then simply fill in the speakers that we need to include in our configuration. We'll call this 916 Dolby, since it matches the path order that Dolby uses within the renderer. Lastly, we need to adjust the channels to conform to this order, starting with the floor speakers in SMPTE order, then the wides, then finally the elevation speakers. Let's create our first source input to route the speakers from the Dolby renderer into our monitor profile. From Sources, right-click and choose Add New Source. Then let's give this an appropriate name. We'll call it DAR, or Dolby Atmos Renderer 916. Select the new group format that we created, which we called 916 Dolby. Then let's work on the channel assignments. Starting with the first row, left, assign the first Thunderbolt 3 channel, then simply ask it to add and assign the next 15 available channels contiguously. Now we have all 16 Thunderbolt 3 channels flowing into our monitor from the Dolby renderer. Let's also create an output set for our near-field monitors, using the same custom group configuration, but this time routing to the 16 DA outputs installed within our Matrix II frame. Now would be a great time to save the new monitor profile we've been working on by accessing File, then Save Profile As. This uses a .dmprof file extension, which is separate from the clock, patching, and ADDA settings, which uses the main file save and writes a .dms file extension. Next, let's check our work and make sure that the Dolby renderer and DADman are in sync when it comes to the 16 channels that we're using for our 916 speaker configuration. From the Setup menu within the renderer, we've opened up the speaker calibration window, which is a great way to generate pink noise to send to your speakers for tuning and trimming. By enabling the signal generator and then clicking sequentially in each speaker field, we can ensure that the signal is traveling from the renderer via Thunderbolt 3 and into the monitor profile using the expected channels and the correct order. The Matrix II includes dedicated onboard DSP resources for speaker tuning of up to 64 loudspeakers with high-resolution filters, trims, delays, and bass management. This functionality will be discussed at length in an upcoming tutorial. Dolby provides users with a way to create a custom HRTF by using a smartphone with their PHRTF Creator app, currently in open beta, which creates a profile unique to your physiology. It provides a better way to experience the binaural output of the Dolby Atmos renderer. Once you've downloaded your personal capture, simply drag the file into the following path, then relaunch the renderer. Now you can simply select the binaural headphone configuration of your choice directly from the pop-up within the main interface. Next, let's return back to DADman and add a second monitor for listening to the binaural output of the renderer and any additional sources that we might want to hear on headphones. From Settings, then Monitor Profile, we'll click on Add Monitor, this time for our Engineer headphones. We'll set the monitor mode to Q, and then assign the Yukon mode to the fourth monitor, or Monitor D, leaving room prior for talent cues we may create at a later time. Let's go to Sources and add a new stereo source called Dolby Atmos Renderer Binaural, or DAR bin. For the channel assignments, if you recall, we told the renderer to send the headphones out on channels 17 and 18, which is using the Thunderbolt 3 I/O on the Matrix II. Next, we need to create an output set to feed into our headphone amp. For this example, we're using a Klang Quell, a low-latency Dante headphone amp which is patched from the first 8 IP audio outputs of the Matrix II. We'll create a new output set called Klang D, which uses the fourth headphone amp, and is being fed from channels 7 and 8 of the integrated Dante outputs. Let's head over to Dante Controller, the alternate patch bay application for all things on the Dante network. From the Devices menu, select Device View, then we can focus specifically on the Klang headphone amp. While looking at the Receive tab, we'll expand the channels for the Matrix II on the right side, then simply drag them over to the Klang. This could also be performed in the main routing view, however the device view is more efficient when patching larger numbers of Dante channels at a time. At the heart of Matrix II is a massive FPGA capable of routing thousands of channels of digital audio to and from a myriad of different formats. For Dolby Atmos workflows up until recently, Dante and MADI have been the I/O formats of choice, capable of distributing the 128 channels of I/O necessary for full Atmos. Now with the Thunderbolt 3 option installed in Matrix II, we have a streamlined solution which can effortlessly connect Pro Tools to our Dolby renderer while still leaving 128 channels of Thunderbolt I/O for connecting streaming services, sound effects management, design, metering, and other DAWs. From the COM patch bay interface, we can select Digilink 1 as the source or input and Thunderbolt as the destination or output. Since each Digilink path is 32 channels wide, we need to create patches from each of the 4 Digilink ports to the corresponding channels 1 through 128 on the Thunderbolt 3 output. Start by command-clicking at the channel 1 intersection to linearly populate channels 1 through 32. Keeping the destination the same, we can select Digilink 2, then once again command-click to continue where we left off, justified now at channel 33 through 64 on the Thunderbolt destination. Continue the same process for the 3rd and 4th Digilink inputs until we've connected all 128 channels from Pro Tools via Digilink into the Thunderbolt 3 destination bound for the Dolby renderer. Now let's connect Pro Tools to the Dolby Atmos renderer. From the Setup menu in Pro Tools, access Peripherals, then Dolby Atmos. For this example, we're using a Mac Studio workstation with HDX II, Matrix II, and the Thunderbolt 3 option installed all in the same system. Tick the Enable button and ensure that the renderer host selected is correct, showing the name of the local workstation in this case. If the green connection status LED is lit solid, Pro Tools and the renderer are communicating properly. Next, we're going to open an example session downloaded from the Netflix Open Content site called Solavante. This content is a great way to exercise your Dolby Atmos system with an excellent collection of professional sessions, all fully prepped. From within the bus tab of the I/O setup, you can see we have a combination of beds and objects already mapped and connected to the renderer. Let's quickly add a mono audio path on output channel 128, which will carry the positional timecode generated from the Dolby LTC plugin from Pro Tools into the renderer. Ensure that the timecode frame rate matches in Pro Tools and in the Dolby renderer, and that the clock button is lit blue in order to receive timecode. From Pro Tools, our current playback engine selection is HDX Hybrid, which gives us a combination of incredible low latency, DSP on demand for recording, and scalable I/O. We can see that we currently have 4 Digilink peripheral connections, 64 channels of I/O connected to the Matrix II chassis, and 64 channels attached to the Digilink expansion card installed in Matrix II. This provides us with a full 128 channels of high-performance I/O to bus from Pro Tools through Matrix and into the Dolby renderer. Within the I/O setup window in Pro Tools, we can see that the Solavante session uses a single 712 bed, plus various objects for each of the different food groups, like music, effects, and backgrounds. There are scenarios where it can be very useful to have Pro Tools automatically conform the bus and output tabs of the I/O setup to match the input configuration from the Dolby renderer. As long as the renderer is connected in the Pro Tools Peripherals menu, simply click on All Buses from the Bus tab of the I/O setup, then choose Use Dolby Atmos Renderer, pre-configured with either mono or stereo object sets. We've now connected 128 channels of audio to and from the Dolby renderer. The first 18 outputs returning back to the Matrix include our 16 speaker channels for our 916 room, followed by the binaural headphone pair. An additional 64 channels of live re-renders can also be added to facilitate loudness monitoring, metering, QC, and even real-time printing of deliverables back into Pro Tools. We'll start with a basic set of re-renders to return back to our DADMAN patch bay and monitor profile. From the Input and Master menu, select Re-renders, then select the layout for the first re-render to create. For this example, we're going to start with stereo, mapped to the first 2 channels available, 19 and 20. For the second set, we'll choose Loudness, which is a dedicated 5.1 output intended for use with a loudness meter, either external or as a plugin inside of Pro Tools. Let's create 2 more sets of re-renders, including a 7.1 and a 7.1.4. By taking advantage of groups, we could also create deliverables composed of specific collections of beds and objects, for example, a music and effects specific mix. Now let's create paths to return the re-renders we created into our working monitor profile in DADMAN. Return back to Settings, Monitor Profile, then expand the sources tree nested within the control room. Right-click and then add 4 new sources. Let's give these appropriate names to match what we created in the renderer. Starting with our stereo re-render, or 2.0, we have a 5.1 loudness re-render, a 7.1, and finally a 7.1.4 re-render. For all these source inputs, we need to match the SMPTE channel order which is coming out of the Dolby renderer. So we've created custom groups for each format to do this. From the Group Formats tab, we can simply select an existing preset group, click Copy Format, rename it, Then by using the move up and move down buttons, adjust each leg to match the desired SMPTE channel order. Right-click to set the mode for each of the remaining re-renders. Now let's assign the appropriate Thunderbolt channels for each set of re-renders. The 2.0 set uses 19 and 20, followed by the 5.1 loudness set at 21 through 26. Then the 7.1 uses channels 27 through 34, and finally 35 through 46 for the 7.1.4 set. Let's hit play on our session to validate that we have audio flowing into the speaker sources, binaural headphones, and each of the 4 re-render sources. Next, let's perform a little housekeeping on our patch bay, which only needs to be done once and will be stored with our main DADMAN DMS settings. We'll first simplify the interface by turning every other view off with the exception of the COM patch bay. Now we're going to label the I/O being sent on the Thunderbolt 3 bus from the renderer into the MTRX II. This helps us to plan and strategize how we can best allocate the available Thunderbolt 3 I/O for other software applications on our workstation. The first 16 sources flowing into Thunderbolt 3 are the Dolby Audio renderer speakers, so we can label them accordingly, followed by the binaural headphones, and then the 4 sets of re-renders that we added. Let's also make a note that if we added additional re-renders, such as for food groups, they would end at channel 82. We'll add a few more inputs, one a 7.1 source for SoundMiner, followed by a return for Max DSP, which can be used for creative signal processing. Next, let's scroll up to the top and examine the outputs on the Thunderbolt bus. If we wanted to route incoming Thunderbolt audio from the Dolby re-renders to external metering applications, we could simply turn those inputs around by patching back to the Thunderbolt bus. Let's allocate starting with channel 201, further down on the priority of output channels we'll use for other applications like routing from other DAWs. We'll create labels for both a stereo and a 5.1 meter destination. And while we're naming channels, let's also allocate the first 12 channels of our Dante input source, which provides us with a way to monitor any streaming audio or video from the workstation in 7.1.4. Next, let's connect a few of our stereo and multi-channel metering applications via Thunderbolt. We'll start with a VU meter from Klanghelm, the VU MT Deluxe, and set it to look for input via the MTRX II Thunderbolt driver on channels 201 and 202. And since the MTRX II Thunderbolt core audio driver is multi-client, it means that we can use the same channel inputs, in this case the stereo re-render output, to feed multiple meters, including decibel from process audio. Now let's create the connection in the DADMAN patch bay while holding down the Shift modifier to add pairs of channels with a single click. We're patching from the source stereo re-render into the destination stereo meter channels that we've allocated downstream on the Thunderbolt 3 bus 201 and 202. Now let's repeat the same process, but this time for surround meters that we can use to analyze the 5.1 loudness set coming out of the renderer. We're assigning from the 5.1 loudness output of the renderer into channels 203 through 208, which will be picked up by both the Flux Analyzer and the Ulean loudness meter applications via Thunderbolt. This gives us the flexibility to use a high-resolution, full-screen metering application on the display of our choice and not just bound to within the DAW. We've just created patch assignments using the routing matrix in DADMAN to feed into multi-channel meters. Alternatively, we can take advantage of the monitor profile to feed digital meters, either internal like software-based Dante, or external devices such as those from TC or RTW. Let's return back to Settings, then Monitor Profile, and expand the control room. Under the meters, we can choose Add New Set to create a new meter group which will automatically follow the enabled source within our control room, either pre or post fader. We'll call this D meter since we're using a new Dante-based software metering application from Zenso. Select the same custom 916 Dolby group we've been using for our sources and outputs, then we'll assign this to the main Dante outputs 17 through 32. From within D meter, we can create custom multi-channel meter presets using any of the available sources that are attached to the Dante network. Within D meter, we've created a 16-channel, color-coded view which can show us our full 916 output in addition to any smaller paths down to simple stereo. Let's first audition the main Dolby return in our control room, then switch to various re-renders, starting with the stereo, then the 5.1, the 7.1, and finally the 7.1.4 re-render. Let's add one last input source to our working monitor profile, a way to listen to the output of any streaming media services on our workstation. including Apple TV, Apple Music, Tidal, and more. Once again, return to the Settings menu in DADman, then choose Monitor Profile, then add a new source under the control room. We'll call this DVS714, which will also be leveraging the custom SMPTE-ordered 714 set we created earlier. We'll assign this to use the first 12 input channels of the integrated Dante and MTRX II. Dante Virtual Sound Card is a simple and inexpensive way to send macOS audio over the IP audio network. When streaming Dolby Atmos, choose a 16 by 16 configuration from the audio channel selection in DVS. Now returning back to Dante Controller, where we can display the device view for the MTRX II, subscribing to Dante Virtual Sound Card for the device called Studio, the name of the workstation, for the first 12 channels streaming into the MTRX II integrated IP audio. From within the audio MIDI setup, simply click on Dante Virtual Sound Card, then choose Configure Speakers, and ensure that the format is specified as 714 Atmos Surround, using channels 1 through 12 in a SMPTE order. Assign the system sound output to use Dante Virtual Sound Card as the default. Now we can stream up to 714 Dolby Atmos audio directly into our tuned control room environment. Pro Tools MTRX II offers immense flexibility when working with immersive audio for Dolby Atmos. Whether connecting beds and objects via Thunderbolt 3, Dante, or MADI, working on projects for music or post-production, monitoring within a calibrated 714 studio, or a massive theatrical re-recording stage, MTRX II provides exceptional connectivity, unmatched audio performance, and the ability to scale as your needs grow.